In this part 1 video, we're going to learn how to apply Excel to solving problems associated with a binomial distribution. The problem here is defined. It talks about Widgeco and manufacturing widgets. The key to parameters that we take out of the problem definition is that we know that 1 out of every 43 is defective and a batch of 150 widgets is produced. So we're going to be asked several questions here around different probabilities of defective widgets, probabilities of greater than 5, exactly 5, between 2 and 11, or equal to or less than 7. So let's go through the process of how we would answer those questions. Step 1, we'll document the key parameters, which is n and p. N is 150, p is 1 divided by 43, or 0.0233 in decimal form. Step 2, we will calculate the expected value, which is simply n times p, and that equals 3.488, and the standard deviation of a binomial, square root of np times 1 minus p. Then we're going to set up a table in order to create our probability model. Okay, as we discussed in class, x will be 0 and greater, but let's fill out this first row. Number of trials is constant, as is the probability of success, meaning success is the probability of a defect, 0.0233. To reiterate, success in the context of P sub s, success doesn't always have to be something positive. So we're going to input 0.0233. Okay? So the problem is asking us questions up to 11 widgets, defective widgets. So let's just make our range of x from 0 to, let's say 0 to 14. The number of trials is constant. Probability of success is also constant. Okay? Now, we have two columns set up here. One is the binomial command for probability density function, which is used to calculate probabilities of the form P big X equals little x. Think of it as if we want to know the probability of, say, 5 defective widgets. The second column is a cumulative binomial function, and it is used to calculate probabilities of the form x is less than little x, where an example would be, let's say we want to know the probability of x is less than or equal to, say, 5 defective widgets. So if we come here to the first row, we're going to hit equal binom distribution. It's going to ask for 4 things. Number / s is x. Trials is 150. Probability of success is column 3. And because this is not a cumulative function, we're going to put false. Okay? So the probability of finding 0 defects in a batch of 150 widgets where the historical probability is 1 out of every 43 is defective, the probability of finding exactly 0 defective widgets is 0.029 or 2.9%. Now, the beauty of Excel is you can drag and drop, and here is the probability distribution for any value of x. Okay, where x is number of defective widgets. How do we check this? Pull the whole column down, go one past, and you see it sums up to 1. Okay, and just to repeat that, let's go down here, Go to auto sum, and it's 1. In order to do the cumulative, same thing exactly except for one input. We go back to binomial distribution. It asks for the same. The first 3 items are exactly the same. We hit each cell with a comma in the middle. But cumulative, yes, put true there. Boom. Okay? So for the first value, where x is 0, 0 defective widgets, you get the same answer as the probability density function, which is 2.91%. Again, you can drag and drop for every value of x that you have defined. Okay? So you can see here, as x increases, it basically, like this row here, adds this value and this value, okay? And then it just cums it all the way up. So you can see that by 9, 10 widgets, we're pretty much have a cumulative of 1. This will conclude this video, and part 2 will address how we use this probability model to answer specific questions.